Hi everyone, thank you for having us. We're very excited to be here and present our talk about Anchor, Bazar, and the Trickbot connection. So a little bit about us. My name is Lior, and I'm a senior threat researcher and a threat hunter at Cybereason. Most of my work is around threat hunting, malware analysis, and open source intelligence. Before joining Cybereason, I was a security analyst in the Israeli Air Force.
Hi, everybody. My name is Daniel. I'm a senior malware researcher at Cybereason. At Cybereason, I specialize in reverse engineering malware and tracking various threats such as nation-state and cybercrime groups.
Today we have a very packed agenda. We will start by discussing the Trickbot gang, describing the group and its operations, and give you some history about the group. We will later cover two malware in their arsenal, starting with Anchor that was discovered last year, and continuing with Bazar, with the Bazar family that emerged in 2020.
We will then continue the talk by discussing code and TTP similarities, showing how all of them are connected to the same actor. One of the most interesting things in the overview of both Anchor and Bazar malware families are the development cycles, which will be discussed in each section. We will then discuss similarities among all three, and finally review how we pivot IOCs and using BT queries to track them
down. So let's start with the Trickbot gang. The Trickbot gang, or as other vendors may refer to as Wizard Spider, is one of the biggest cybercrime groups operating in the world today. The key members are thought to be Russian-speaking, and they are involved in a wide range of cybercrime activities. Their tools are known to check for Russian language presence on the system, which is also known for other Russian threat actors, and terminate execution in case it does. This way, they try to evade infecting Russian users. The group is also known to develop their own tools, including their most famous Trickbot malware. We can even say that the Trickbot gang is a sort of a cartel. They have a whole ecosystem and a partnership with other threat actors and gangs, and a whole arsenal of tools, posing as one of the biggest threats to organizations and businesses worldwide. These gangs that they partner with vary from ransomware operators to online spammers, fraudsters, and more. Actors who lease tools from the Trickbot gang can use the Trickbot Trojan to install their own malware or to use the available Trickbot modules, depending on what operation they want to carry out on the infected hosts. It is also worth to mention that they do not list their tools and services to any threat actor. The Trickbot gang are not using the classic mass module, but instead they choose their customer and partnership very carefully. In fact, it is not open to everyone, and in order to work with the Trickbot gang, one must go through a validation process and also have someone vouching for them. Besides Trickbot, the group is also responsible for other malware, such as the Anchor DNS, and Bazar Loader, which we'll talk about a bit more and present the connection among all of them. If we want to build a timeline for the Trickbot gang, it will look something as follows. The initial emerge of Trickbot in 2016, Anchor in 2018, Anchor DNS in 2019, and finally the Bazar Loader in 2020. So let's talk about the Trickbot malware, the oldest malware in the gang's arsenal that also gave the team its nickname. Trickbot is usually referred to as a banking Trojan, but it's actually more than that. It is a modular information stealer that has modules for reconnaissance, credentials, and sensitive information harvesting, and in addition has modules that target specifically banking information. Trickbot was first discovered in 2016, mainly targeting individual users and stealing financial information. Later, around 2017, 2018, we started to notice a shift in Trickbot's targets as they became more business and organization-oriented. One of the most famous examples, perhaps, happened in 2018, involving the infamous triple threat of malware, Emotet, Trickbot, and Ryuk. that caused substantial damage worldwide. During an investigation, we came across this attack tree. The way that Trickbot operates is that it injects its malicious modules into another process. And as we can see here, Trickbot injects its modules into SVC host and uses it to carry out the malicious activities. One of Trickbot's module is a module that is in charge of the reconnaissance activity. This module uses built-in tools such as net commands, ipconfig, and nltest to collect information about the network and the users. And the reconnaissance activity helps to determine who is the victim, an individual or an organization, and the results are sent back to the attackers, which based on that choose their next steps. If the victim turned out to be a worth infecting or high-profile target, an interactive operation will take place, such as the one in this scenario where the attacker used Interpreter to deploy secondary tools and Cobalt Strike to move laterally within the attacked network. Now that we've got some background and we saw how Trickbot infection led to an interactive hacking operation, let's have a look at another tool in the gang's arsenal, the Anchor malware family. So we've shown you this attack tree that we've investigated, and maybe the sharp-eyed among you have noticed that one of the tools delivered in this incident was a malware from the Anchor family. Anchor is a backdoor that again was saved against high-profile targets. It was observed infecting victims across the United States and Europe, where the main targets were companies in the financial, manufacturing, and retail sectors. It was first observed in 2018, when it seems that the Trickbot gang wanted to expand the arsenal a bit, and from the detection rate on VirusTotal, it appears that they've worked very hard to keep it under the radar. It was almost completely undetected for almost 2 years by various security tools. In the different attacks involving Anchor, it was observed delivering POS, point of sale malware from the gang's arsenal that was used to steal credit card data. The Trickbot gang has a pretty decent development cycle. As we have seen, they work very hard to try to evade detection and adding more capabilities to their malware. 1 year after Anchor was first observed in the wild, a new evolved version of it was discovered and called Anchor DNS. Anchor DNS was added with DNS tunneling C2 communication and other features and tweaks such as string encryption and code obfuscation. As we have seen with Anchor, and since it was used for the same purpose, just with enhanced capabilities, it was also deployed as a secondary payload of Trickbot and was used to target the same sectors in the same regions. Another cool feature that we've seen in Anchor and definitely contributed to it remaining undetected for so long is the usage of flags to operate. In order to execute properly, command and arguments had to be supplied to the Anchor executable. This way, each execution without the correct flags or without any flags will result in the sample not running, which helped it to evade sandboxes and also making it harder to analyze manually. So we've talked a bit about the development cycle of Anchor. During our research, we came across 2 variants of Anchor DNS. Here are some of the main tweaks and improvements between the variants. In the first Anchor variant discovered in 2018, the GUID was saved in clear text. It had some code obfuscation, and it uses the standard HTTPS protocol for C2 communication. In the older Anchor DNS variant discovered in May 2019, the GUID was encrypted using base64. It had some code obfuscation as well, and it started to use DNS tunneling for C2 communication. This was a step forward in making the malware less trivial to analyze, and in addition, avoid communication detection. In the new Anchor DNS variant that was discovered in November 2019, the GUID was encrypted using base64 as well, and the code was massively obfuscated. The developmental step was made to hide the malware's core functionalities, and together with the network detection evasion and the previously mentioned necessary command line arguments, Anchor remained under the radar for a long time. In 2020, a Linux variant of Anchor was discovered. From looking at its code, it is clear that it resembles its older brother, Windows variant. This is yet another successful result of the Anchor's family latest development cycle. On the left image, you can see the hard-coded Anchor Linux name, and on the right, you can see the command line parameters passed to the Linux binary. Both of these characteristics resemble to the Windows variant that we have mentioned earlier. And now I will hand it over to Daniel to present the Bazar Loader and discuss the connection to Trickbot and Anchor.
Thank you, Lior. So the next step of the Trickbot gang was developing another malware that was also used against high-profile targets in the US and in Europe. Since it used Emmerco and Bazar domains, it was named by researchers as Bazar Loader. The usage of Bazar domains started to become more and more popular with threat actors, and here's why. Quoting from Emmercoin.com website. Because of Emmercoin's secure and distributed blockchain, the domain name records are completely decentralized and uncensorable and cannot be altered, revoked, or suspended by any authority. So you can see the appeal here for threat actors. The first variant emerged around March 2020 and the last one in June 2020. As we can see in the graph depicting the infection chain, like many other attacks, it all starts with a phishing email that lures the victim into downloading Bazar Loader from Google Docs, while the executable itself is masked as a PDF file. One of the first things we noticed is that developers had rapid development cycles. They have clearly evolved and learned themselves through the whole process. Now let's have a brief look. Let's have a brief look at the Bazar family development cycles and discuss some of the changes implemented as the malware's variants advance. So the Bazar family is both a loader and a backdoor. We will focus on the loader. In general, it's clear that the authors invested a lot of time into obfuscating the malware. The first debug variant that was first seen in April 9th, somewhat in parallel with the first operational loader variant, was relatively easy to analyze. It wasn't obfuscated or encrypted. It actually had a very clear log file that showed the malware's operation. It didn't try to hide itself from analysis tools. It also had the Team9 debug strings, from which the name Team9 was derived. More on that in the next section. The second variant, which is the first operational loader, was active between the end of March and the middle of April, and it started implementing heavy obfuscation. This was expressed in multiple algorithms to hide strings and to also hide API calls. After almost 2 months of silence, a new variant emerged in June 2020. This variant was featuring heavy obfuscation as the previous one, but also implemented new features such as domain generation algorithm, or DGA, and the API hammering technique, which creates thousands of redundant API calls to spam Sandbox's report and also delay the sample's execution. In conclusion, each development cycle was productive for the developers, introducing new features to serve their purpose of analysis and detection for them. So up until now, we talked about Anchor, reviewed Bazar Loader, and also mentioned Trickbot. As you may notice, there are several interesting similarities they all share. Let's move on to exploring some of these similarities. The first noticeable similarity is the initial infection vector of Trickbot and Bazar Loader, which is pretty much the same. It consists of a phishing email that, instead of an attachment, contains a link to a Google Doc. Once the user browses to read the Google Doc, they will be presented with a message instructing them to download the document and open it locally on their computer. To lure the victim, the Bazar or Trickbot loader is masquerading as a Microsoft Office or Adobe PDF file by using their icons, sometimes with a double extension, such as .pdf.exe or .doc.exe. Since common extensions are not usually presented by default, the unsuspecting user will simply double-click on the file. Both Anchor and Bazar Loader, in their early variants, exhibit verbose logging of their activity on the infected machine, giving the developer, but also the analyst, a clear view of what the malware is up to. In this snapshot of Anchor DNS log, we can see the GUID created for this particular machine and other file-related activity. In this log file of the early Bazar Team 9 loader, we can see a nice log that shows the communication to the C2, followed by downloading and decrypting its payload, which is the Bazar backdoor. It will even show the size of the backdoor and if the payload is okay or not, and if it was verified successfully. Another notable similarity is the usage of signed samples. In some cases, Trickbot and Anchor samples were signed with the same certificates. These certificates can be used as a good detection mechanism for further Trickbot-related malware.
Another very strong connection is a shared C2 server between Trickbot and Anchor. This IP address that is shown on the slide was hard-coded in both malware, Trickbot and Anchor, which leaves no room for doubt about the malware's connections and shared infrastructure. You can also see here the VirusTotal graph that shows that both Trickbot and Anchor samples share the same C2. Another similarity is that all of the discussed variants are using a very similar pattern to create a unique identifier for each infected machine and then access it as a resource in the C2, most likely creating a separate folder on the server for each infection. This is a known pattern of the Trickbot gang and can be seen in multiple communication logs.
Here we can see the known Trickbot decryptor on the right using the virtual alloc EXNAME API to allocate memory used to run the decrypted shellcode. On the left is Bazar Loader, which is very similar, if not almost identical to the Trickbot loader. Both of them will load the above-mentioned API, encrypted shellcode, and also a PE, together with their sizes and the decryption key. Finally, the decryption routine will be executed and decrypt the shellcode, which in turn will run the PE. The shellcode and the PE are both further obfuscated with dynamic API loading and other strings obfuscation used to hinder analysis and detection, as we saw earlier.
Last but not least, instead of using the standard C2 communication, such as HTTP or HTTPS, both Anchor DNS and Bazar Loader make an effort of evading C2 communication detection by using more advanced techniques, such as DNS tunneling, Immer DNS, and domain generation algorithm. It is worth to mention that the Anchor family was also seen at some point using the Bazar domains. As you may notice, their communication protocols are not the same, but both are oriented to avoid network communication detection. So we mentioned briefly the use of VirusTotal. Let's see how we use VT in our investigation and show you some tricks and handy queries that we use. So as part of our research process, we use different OSINT tools to collect additional information about the group or the malware we want to investigate and hunt for additional samples and TTPs related to data. One of the more known tools is VirusTotal, which is a platform that we use to run advanced hunting queries and YARLs to search for files with specific metadata, content, file type, behavior, and more. VirusTotal has a variety of data points and filters that can assist finding additional IOCs, which can later be pivoted and extended. In our research, we often use static data queries along with behavioral information supplied by VirusTotal and other sandbox vendors. For example, the investigation of different samples we observed in the Trickbot Anchor campaign led us to create a list of signers, which we use to hunt for other samples related to the same campaign using the signature filter in VT. We can also use the VT graph feature to search for connection between samples and the infrastructure, as shown here, and as we've discussed in the section of the C2 overlap with Anchor and the Trickbot. There is a lot more we can do with VirusTotal, and since we don't have all the time to show you all of this in this presentation, we highly recommend you to learn more about it and become familiar with the capabilities and the filter options.
So let's wrap things up. In today's talk, we discussed how the Trickbot gang also operates together with other actors by providing them with infrastructure or by allowing them access to infected hosts. This model of malware as a service, or MAS, is gaining more popularity and allows threat actors to collaborate among them to increase their revenue.
The Trickbot gang in particular is interesting because of their development cycles of custom-built tools, as well as their expertise in evading security solutions.
One of the most important words of advice we can give you, fellow researchers and analysts, is to focus on TTPs rather than just chasing IOCs or relying too much on AV signatures. Attackers can obfuscate and pack their payloads, but no matter how obfuscated or encrypted the payload is, it has to interact with the operating system at some point. This is where behavioral-based detection comes to play. Finally, in a world of nation-state malware and APTs, it's sometimes easy for us as analysts or researchers to underestimate the potential damage that commodity malware can cause. Similar to what Trickbot and other malware taught us, what starts as a small and trivial infection can later turn into a fully fledged hacking operation with disastrous outcomes.
So we've covered a lot in this short session. For those of you who are interested in learning more about the Trickbot gang and the new malware and tools, we encourage you to visit our blog and reach out to us on social media if you have any questions. That's all from us. Thank you and stay safe.
Thanks again for having us. Bye,
Bye.
everyone.